Okay, let's continue our class. Uh, Sorry, the connection was a problem. So let's continue our class. So we are discussing convolution sum method, which is used to calculate or determine the response of a system given. As you can see here, input is given. Uh, Input signal is given. Here the arrow indicates n is equal to 0, as we have said. For impulse response, the arrow is here, which is n is equal to 0. So impulse response of a system, a LTI system, is given. So we have a LTI system here, linear time invariant system. With impulse response h of n. H of n is 1, 0, minus 2, 3. 2 is at n is equal to minus 1. This is n is equal to minus 2. The sample is 0. N is equal to minus 3. The impulse response is 1. So this now we apply input. We apply input signal x of n here. As input x of n is applied, you can apply any input signal for this system. So we are asked to determine the output y of n. What is the response of this LTI system with impulse response, as you can see here, is given, and input signal is given. So we are asked to calculate y of n using convolution sum. Convolution sum, very important mathematical equation, which is used to determine the response of a system if impulse response and input is given. So we can calculate. There are so many methods. So in this case, we'll see the easiest one, which is tabular method. Okay. So input signal is given. As you can see here in this table, in this table, in this this one is input, and this one is h of n. So input is given. So we write. We are going to write our input here. So what is the first value of input? 2 here, right? Then minus 1. Next value of input is positive 4. So I'm writing input on the horizontal. Vertically here, in this direction, vertically, we write the impulse response. Impulse response is, what are the values? 1, start from here. What is the next sample? 0, next sample, minus 2, next sample, 3. So as you can see here, you write input signal horizontally, impulse response vertically, or you can change, no problem. Input signal vertical, or impulse response horizontal. Next, what we have to do? The next step is multiplication. As you can see from the formula of impulse response here, x of k and h of k is multiplication. So the first step is multiplication. So we have to multiply here. So 1 times 2 will be 2. We multiply each sample of h of n by all x of n. So 1 times 2 is 2. 1 times minus 1 is minus 1. 1 times 4 will be 4. Okay, next, Next, we shift by 1. We jump 1 here. I'm not writing anything here. So the next one here, it will be the next sample h of n, which is 0, multiplied by all x of n. So 0 times 2, it will be 2. 0 times minus 1, it will be minus 1. And 0 times 4 will be, sorry, it's multiplication. So 0 multiplied by 4 is 0. 0 multiplied by minus 1 is 0. Then 0 multiplied by 4 will be 0. Okay, next row here. What is the next sample? Minus 2. H of n is minus 2. But before multiply, we shift now by 2. We jump or skip 2 spaces here. Okay, then multiply this h of n by all x of n values. So minus 2 times 2, it will be minus 4. Minus 2 times minus 1, it will be 2. And minus 2 times 4, it will be minus 8. Okay. Next, we have 3. Impulse response is here, the last sample, 3. Then in this case, we shift by 3. We jump 3 spaces here. Why we do shifting? On the formula, as you can see here, h of n is shifted by k. So shifting operation is there. So after shifting 3 times now, multiply again. 3 times 2, it will be 6. 3 times minus 1, it will be minus 3. 3 times 4, it will be 12. Now we finish first. Look here. What we have done, I multiply this 1 by 2. I write it here, 2, right? So 1 times 2, 2. 1 times minus 1, minus 1. 1 times 4 is 4 here. Next, we jump by 1 space because we shift. Then multiply this h of n. Here h of n next value is 0, right? We start from 1, then next is 0. We write this 1, 0, 2, 3 here vertically. 1, 0, minus 2, 3. That's impulse response on this side. On this side, we put what? The input. What are the inputs? 2, minus 1, and 4. So I put it here, 2, minus 1, and 4. These are my inputs. Okay. So, so multiply 1 by 2, we get 2. 1 times minus 1 is minus 1. 1 times 4 is 4. Next, jump 1 space, shift, because convolution is multiplication, shifting, and addition from the formula. We have to multiply. We need, as I said, to calculate output using convolution, we need 2 functions. What is the first function? Our input. Second function, impulse response. So input, you write it here. Impulse response, we write it here vertically. Then the first step, multiply 1 times 2, 2, 1 times minus 1, minus 1, 1 times 4, 4. Next, shift by 1. Then again multiply. 0, the next impulse response, multiplied by 2 first. 0 times 2, 0 here. 0 times minus 1, 0 again. 0 times 4, again it is 0. Next step, we jump how many? 2. Jump means shift. Again multiply the next impulse by the input. So minus 2 times 2, minus 4. Minus 2 times minus 1, positive 2. Minus 2 times 4 here, it will be what? Minus 8. Next step, jump how many times? 3 times. Shift 3 times. Again multiply the last sample 3. Impulse or last sample of impulse is 3. Multiplied by 2. 3 times 2, it will be 6. 3 times minus 1, minus 3. 3 times 4, it will be 12. Now we finish here, come to our formula here. First, x of k multiplied by h of k, then shift by k, we shifted. Finally is what? Summation. Okay, we have to add these multiplications together. So what we should do? We multiply now vertically. Don't be confused. Don't add this part. This part is our input. Okay, this part is what? Our impulse response. This part is the result. So we add now vertically. This in this column we have only what? We have only 2. So we write it here, the result, summation. How about in this row? We have 2 samples, -1 and 0. So when you add -1 and 0, it will be -1. I am adding. Next, in this column, I have 4 here, 0 here, -4 here. When you add, it will be what? It will be 0, -4 plus 4. Next column, here I have 0, 2, and 6. What is the summation? It will be, summation will be 8, 6 plus 2 plus 0. Next row, we have 2, -3, and -8. So when you add, it will be -11. Lastly, we have only 12, so it will be 12. Okay, so this is our output. We'll do many examples until it is clear for you. So this is our output. Okay, our output 2, -1, 0, 8, -11, and 12. Okay. Now, we can do it using MATLAB. Okay, can you see the MATLAB? Anybody? Okay, so x, our x input 2, comma, -1, comma, and 4. That is our input, right? That's our input. What is the impulse response of this system? H is equal to 1, comma, 0, comma, -2, comma, and 3. This is our impulse response. H of n and x of n are given. Now to calculate the output, you write simply y is equal to conv, C-O-N-V, input is x, comma, what is our impulse response? H. In our program, I give x here, I give h here. Now calculate y by using what? By using convolution. So when you press enter, it will give us the output y. What is the output? It is what? 2, -1, 0, 8, -11, 12. Exactly, the exact answer we get in our tabular method. Okay, so in our tabular method, this, when you add this, it will be 2. When you add -1 and 0, it is -1. You will see here. 4 plus -4 is 0. 2 plus 6 is 8. -3 minus 8 is -11 here. And finally, we have 12. The same answer using the simple formula. You write only what? Y is equal to conv x, comma, h. It will give you the output. What is conv means? Convolution. We'll see more examples until it gets, just as I said, there are so many methods to calculate convolution. Graphical method, the definition itself, tabular method, polynomial multiplication. There are so many methods. But for me, this tabular method is very easy to perform convolution sum. Let me repeat this one. Let me repeat once. But before that, can you hear me? Okay, so let me repeat once to these tabular methods. So input signal is given, as you can see here. Input signal is given 2 minus 1 4. This is the arrow at n is equal to 0. Impulse is given 1 0 minus 2 3. So input 2 minus 1 4, we write it here 2 minus 1 4, right? Impulse 1 0 minus 2 3, we write it here 1 0 minus 2 3. Very simple. Any input given, you put it here on this row. Impulse response, we put it here vertically. Then next what? Next, the first impulse multiplied by each input samples. So 1 times 2, 2. 1 times minus 1, minus 1. 1 times 4, it is 4, right? Next, the next sample h of n, which is 0, multiplied by again each sample of the input. Okay, but when you write your answer, you have to shift by 1. Don't write here. Shift by 1, then multiply 0 times 2, 0 here, 0 times minus 1, 0 again, 0 times 4, 0 again. Next, what's the next sample? Minus 2 here, impulse response. Again, it's multiplied by each sample of the input. Multiplication here, as you can see here. But before that, in this first case, no shift. Here, there is no shift. Second part, there is a shift by 1, right? Second part, shift by 2 times. Okay, then we multiply this minus 2 by each sample. Minus 2 times 2, it is minus 4. Minus 2 times minus 1, it is 2. Minus 2 times 4, it is minus 8. Okay, next, shift how many times now? 3 times. Okay, after shift 3 times, again multiply input by each, impulse by each sample values. So 3 times 2 is 6. 3 times minus 1, minus 3. 3 times 4 is 12. What is the next step? Next step, addition. Okay, so don't add 2 and 2 here. Don't add these 2. We only add the result. The result is 2. So is there any other sample here? No. So we have only how much? We have only 2. Next, this case, we have 2, minus 1 and 0. So summation minus 1. Next, 4 times minus 4. 4 plus 0 plus minus 4. Summation will be 0. Next, we have 0, 2, 6. When you add it, it becomes 8. Next, minus 8 minus 3, we have minus 11. Finally, we have 12. Okay, that is our output. So output has how many samples? 1, 2, 3, 4, 5, 6 samples. What is the input? The input is only 3 samples. After processing, this system with impulse response, this generates which output? It generates this output. So we'll see more example until it gets clear for you. So to revise what we have discussed so far, convolution is very important mathematical tool for to determine the response of LTI system given input signal and impulse response. As I said, if you have non-periodic, this input signal is non-periodic. It does not repeat itself. For non-periodic signal, we have a convolution called linear convolution. Okay, there are different methods, but I think this tabular method is the easiest way to calculate a response, to calculate the convolution of linear time invariant discrete time systems. Okay. Any question? Mohammed, you asked me where the arrow below the output. Very good question. Mohammed, can you hear me? Mohammed Jam. Hello. Okay, where the arrow below y of n number 11 comes from. Okay. Let's take a few minutes and we'll finish our class today. So, okay, so as I said, output will be y of n will be y of n is equal to, what is the first one? We add this, we get 2, comma. The next one, -1 and 0, we add, we get -1. Next, 4 and -4, we get 0. Next, it is 8, right? 2 plus 6. Then here we have -11, -11, and here we have 12. This is the output, right? The output. Using what? This simple linear convolution method. Now the question is, where is the arrow for the output? For the arrow for the input is where? At -1. For impulse response, where is the arrow? At 3. Okay, now how many samples to the left of the arrow for the input? How many samples to the left? We have only what? 1 sample to the left. For input, we have only 1 sample to the left of the arrow. For impulse, for our impulse, how many samples before the arrow, to the left of the arrow? There are how many? There are 3 samples. So, plus 3. 1 for input. For input, to the left of the arrow, we have 1 sample. For impulse response, to the left of the arrow, we have 3 samples. We add this to 1 plus 3. How many? 4. So you come to the output. To the left of the arrow, there must be 4 samples. So we are here 1, 2, 3, 4. So we put the arrow here. For the output. For the output, to the left of the arrow, how many samples? 1, 2, 3, 4. How do you know it is 4 samples before the arrow? Here, when you come to the input, this is where this is the arrow position. So we have only 1 sample to the left. 1 plus How about the impulse? 3 samples. So 1 plus 3. For the output, it will be the summation. So 1 plus 3, it will be 4. So for the output, to the left of the arrow, we have 4 samples. So the arrow for our output is here. Okay. What does it mean by the arrow? Arrow means the value of this signal when time is equal to 0. Another thing, input, how many samples? 2, -1, and 4. So how many samples total? 3 samples. Impulse response, how many samples? 1, 2, 3, 4. Plus 4 minus 1. We subtract 1 always. This is the length of input plus length of impulse. How much? It will be 7 minus 1. So the length of the output always must be 6. So this is the formula. What is the length of the output? Is equal to length of input, how many samples of input, plus how many samples of impulse response, h minus 1. This formula you use to calculate numbers. In output, how many samples? 1, 2, sorry, in output, 1, 2, 3, 4, 5, 6. Why it is 6? Because this is the formula. Length of output is equal to length of input plus length of impulse minus 1. This one is to calculate how many samples in the output. To calculate, to determine the position of the arrow, what we should do? What is the number of samples for x of n to the left of the arrow plus number of samples for impulse response to the left of the arrow? We add these two, it will be 4, so we put our arrow here. So we'll discuss another examples until it gets clear for you. Okay, so you said you understand, teacher. Any other question? Otherwise, we'll finish our class today. Okay, see you next class.